Our lesson today is to be able to find the percent increase, percent decrease, and also the percent of error. All right. When we find percent change, we use a formula. The percent change is equal to the amount of change over the original amount. I like to, though, use a different term instead of amount of change. I like to use the word difference, because the word difference actually gives us a clue as to what operation, or it gives us more of a clue as to what operation we're going to have to use. All right, so we use difference divided by the original amount, and then we have to multiply by 100, because the word percent means out of 100, and when we do the difference divided by the original, we get a decimal value, and then to change any decimal to a percent, we would have to multiply by 100. So let's take a look at our first example. It says the table shows the number of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? All right, well, we see Saturday that we spent 2 hours online, and on Sunday we spent 4.5 hours online. All right, and my percent change formula, oops, I don't like that. My percent change formula, all right, percent change, I use the following formula, change is equal to the difference divided by the original times 100. All right, so we're going to use that formula to find the percent of increase here. So to find the difference, we subtract the smaller number from the larger number. So the larger number goes first, we subtract the smaller number. The original amount, the denominator, would be the Saturday time that we spent online, and then we want to multiply that ratio by 100. So when we take 4.2 and subtract 2, we wind up with a 2.5. 2.5 divided by 2 times 100, we wind up with, what's that percent change? Let's see. So when we do 2.5 divided by 2, right, we wind up with 125%, right? And that is a percent increase. All right, and that's simply 4.5 minus 2, that's 2.5. 2.5 divided by 2, that's going to be 0.5. 0.5 divided by 2 times 100, we get 125% increase. All right. These next two examples, we want to be able to find the percent change. We use that same formula. We find the difference first, so we subtract the larger number and the smaller number. We divide by the original amount here, which is 10, and we multiply that by 100. All right. So that's going to be 25 minus 10 is 15. 15 divided by 10 times 100, that's going to be 150% increase, because we're going from 10 to 25. So 150% increase. From 57 people to 65 people. Right? Same formula. 65 minus 57, divide by the original amount, which is the 57. Then we have to multiply by 100 because we want the percent. So when we do 65, take away 57, that's going to be 8. Divided by the 57 times 100, right, we get a 14% increase there. All right? The key, making sure that we have that bottom number correct. If we're going from a smaller number to a larger number, we're finding the percent increase, and when we find the percent increase, that smaller number is in the denominator. All right? And that's what we see in both examples. Next problem. We want to find the percent of decrease. Here it says the bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013? Well, in 2012 there were 28 home runs, and in 2013 there were 20 home runs. So once again we want to find that difference. So it's going to be 28 minus 20 divided by the original amount. Well, because it's a percent decrease, the original amount will actually be the larger amount here, right, times 100. So when we take away 28 and 20, that's going to give us 8. We divide 8 by 28 and we multiply that by 100. That's going to give us a 28.6% decrease. 28.6%, that's a decrease because we're going from a larger amount of home runs, which is 28, to a lower amount of home runs. Next example. Yusef bought a DVD recorder for $280. Now it's on sale for $220. Find the percent of change in the price. Round to the nearest whole percent if necessary. Well, they started at $280, then it's on sale for $220, right? So we need to find that difference. The original amount was the $280, and then we multiply by 100, right? It's the difference divided by the original times 100. Well, the difference here of 280 and 220 is 60. We divide that by 280, and we multiply that by 100, and we get a 21.4%, right? And that's a decrease. Right? 21.4% decrease. All right. Let's try example A. Find the percent of change from 10 to 13. All right. So if we're going from 10 to 13, I'll call it example A here. The difference, 13 minus 10, divided by the original amount, which was 10, times 100. Right. That's going to give us a 30% increase because we're going from 10 to 13. Problem B, the difference would be 20 minus 15 divided by the original amount. Well, it was 20, now it's on sale for 15, so the original amount was 20, so we're actually looking for a percent decrease. So we have 5 divided by 20 times 100, that's going to give us a 25%, and that's going to be a decrease. Alrighty. Next part of the lesson, we want to learn and be able to calculate what's called the percent error. And the percent error is simply the percent that an estimated quantity differs from the actual amount. The ratio that we use for percent error is the amount of error divided by the actual amount. But once again, I'm just going to add to that formula that we're going to multiply that by 100 because we get a decimal value, and to change that decimal to the percent, we multiply by 100. So here's our first example. You estimate the length of your classroom at 16 feet. The actual length is 21 feet. Find the percent of error. Well, the difference would be 21 minus 16. So the amount of error would be 5. Divide by the actual amount. Well, the actual amount here is 21. We want to multiply that by 100. All right, so that's going to be what? 5 divided by 21. Multiply that by 100, and we get a percent of error of 23.8. Right, that would be the percent error for that problem. All right. All right, let's do this example, example 4, another percent error problem. It says in example 3, your friend estimates the length of the classroom at 23 feet. All right, that's the estimate. We know the actual was 21, so the amount of error is going to be only 2. All right, we know the actual amount is 21, and then we're going to multiply by 100. So that's going to be 2 divided by 21 times 100, and that's going to give us a 9.5% error. So who had a greater error, the greater percent error? That would be you, right? Because 23.8 is greater than 9.5. All right? Okay. Well, let's see. Let's try this percent error down here. It says to find the percent error if the estimate is $230 and the actual amount is $245. Right? So step number 1, we find the error, the amount of error. So that would be 245 minus the 230. But then we have to divide by the actual amount. The actual amount here is 245, and then we're going to multiply that by 100. All right, so that's going to be the amount of error is 15. Divide that by 245, and we multiply that by 100. And we want to round to the nearest whole percent. So that's going to give us 6% error. All right. Now, last part of the lesson, we're actually given a percent here, right? 55 employees increased by 20%. So instead of finding the percent increase or the percent decrease, we're actually given the percent increase or the percent decrease, and we're being asked to find the new amount. All right, now there's two different ways to do these problems, right? We could do them in one step, or we could do them in two steps. All right, we're going to do problem one first, all right? And we're going to do problem one in two steps. The first step is to take the percent, and anytime we write a percent, all right, we put it over 100. And we're going to do this problem using a proportion. Well, the whole amount of employees, or the total employees, is 55. And we know the whole amount always goes in the denominator of our percent proportion. So in the numerator, we're going to have n. When we cross multiply or find the cross products, 100 times n is 100n. 55 times 20 is going to be 1100. And when we divide both sides by 100, they cancel. N is equal to 11. But that's only step one. The question asks us to find the new amount. So we found the 20% increase in employees. But to find the new amount, we then have to add the original amount. So we take the 20% increase, which is 11, we add the original amount, which is 55, and we get 66 employees as our new amount. Now that's how you would do the problem if you're doing it in two steps. There's a way to do the problem in one step, and sometimes students like to do the problems in one step. So if I'm doing it in one step, here's what we have to realize. That if we're increasing those 55 employees by 20%, the new amount percent is going to be 120% of the original amount. Now, where did I get 120% from? Well, the 55 employees represents 100%, and then we're adding the 20%. So we want to know, well, what is 120%? So I put 120 over 100, and I still have my n over 55. So if we do this problem in one step, find our cross products, we get 100n. It's going to be equal to 6600. And when we divide both sides by 100, we wind up with n is going to be equal to 66. So some students like to do the problem in two steps. Some students like to do the problems in one step. Right? You choose whether you want to do it in two steps or one step. Now that's what an increase looks like if we increase the population or increase something by a percentage. What would a decrease look like? Well, let's take a look. We'll do problem over number 2 over here because it's a decrease. Problem number 2 says we take 25 degrees and we're going to decrease it by 60%. So we start with our ratio that's given, 60 over 100, and that's going to be equal to n over 25, because 25 is the whole amount. That's what we're starting with, but we're going to decrease that amount. So once again, the 25 is going to go in the denominator of our other ratio. Use our cross products property. So 100 times n is 100n. 60 times 25, that's going to be equal to what? That is 1500. And when we divide both sides by 100, divide both sides by 100, they cancel. N is equal to 15. But 15 represents the decrease. So when we're decreasing an amount, we have to take the original amount, which is 25, and then we have to take away the decrease, which we just found, and that's going to give us 10 as our answer. All right, but that's two steps. We find n, and then we have to take that decrease away from the original amount. What does that problem look like with one step? Well, with one step, it's going to look like the following. All right. Well, if we're going to decrease something by 60%, we're taking 60% away from 100%, and that leaves us with 40%. All right. I'll say that again. If we're decreasing something by 60%, we're taking 60% away from 100%, and that leaves us with 40%. So our ratio is going to be 40 over 100 equals n over 25. We still use our cross products property. We get 100n is going to be equal to 1,000. And when we divide both sides by 100, we wind up with n is going to be equal to 10. So we can do these problems in 1 step or 2 steps. All right, so that's a few examples of the lesson that we worked on today. First, we found the percent increase or decrease, which we called percent change. Next, we found percent error. And then the last thing we did was we found the new amount if we were given an increase in a percentage or a decrease in a percentage. All right, I hope that has been helpful, and we'll see you soon.